Good afternoon. We are going to take notes on pre-chapter 7. The topics are reducing ratios and solving proportions. This is going to be the algebraic base for the skills that we need the rest of the chapter. All right, let's get started. Roman numeral 1, reducing ratios to simplest form. The definition of a ratio is a fraction. And it's a fraction that compares two different quantities. So one example of a ratio would be 2 shirts for $6. Notice the word for separates the top from the bottom. The other one would be something like a 3-foot side of something per 2 feet of base. So you're going to hear the words per a lot, or for, which indicate the fraction bar. All right, if two pairs of objects reduce to the same ratio, but start with different quantities, they are called similar objects. So again, it's how do you take two pairs of objects that start with different quantities but reduce to the same thing. So an example of that would be $4 per 12 cans of something versus $1 per 3 cans. They look different in the beginning, but if you reduce the one on the left, you have $1 per 3 cans, which is the same as $1 per 3 cans on the right. They started out differently, but they ended up the same. This is where similarity comes from. These two quantities, these two ratios, are similar because they reduce to something that is equal. So the process for reducing, there's some steps. The first step is to prime factor the top and bottom of the ratios, divide any equal factors to 1, and then re-multiply the remaining factors. You also must simplify the signs. So we're going to start with just basic quantities, and then we'll work our way up to actual units and how we deal with them. All right, so example 1, 5x over 10x squared. 5x factors into 5 times x. 10x squared factors into 2 times 5, x and x. So now what we do is divide any equal factors to 1. So 5 goes into 5 one time, x goes into x one time. So now what we have is 1 times 1 on the top and 2 times x on the bottom, which we finally simplify into 1 over 2x. Notice that we're not really canceling. That word is not very accurate. We're actually dividing the bottom into the top one time. So there is actually a 1 there. Something that happens rather frequently is when everything divides out, students forget that there is a placeholder 1 at the top, and they accidentally move the 2x up, but it is indeed on the bottom. All right, what if there's a negative in front of a number? Okay, so when you factor a negative number, the negative becomes its own -1. And then 28 is 4 times 7. Then I've got g cubed. So you can start with 4 times 7 or 2 times 14. You'll end up with the same thing at the end. 12 is 6 times 2, and then I have a g squared. So start with any two numbers that multiply to get what you get at the start, and then expand from there. So I have a -1. 4 is 2 times 2, 7 is a prime number, and then we have g cubed, which is g times g times g, all over 6, which is 3 times 2, another 2, and then g squared, which is g times g. When everything is completely prime factored out, you need to divide out similar factors. So 2 divides into 2 one time, 2 divides into 2 one time, G divides into G one time, another G divides into G one time. The cool part about doing your reducing like this is at the end you are absolutely 100% reduced, and there's no guesswork trying to figure out if there's anything else that can come out of it. You are totally done. It's a great method. -1 times 7 times G is -7G on the top, and then I have a 3 on the bottom. All right, let's work with double negatives. I have a -42, so a -1. Now, I'm going to do this in one step instead of two. This is a two-step prime factoring. I'm going to do this in one. 42 is 6 times 7. 6 is 2 times 3, and then I have a 7, and then 4 ends. On the bottom, I have a -1. 16 is 4 times 4, so 2 2's for the first 4, 2 2's for the second 4, and then I have 6 ends. 1, 2, 3, 4, 5, 6. That's prime factoring in one step. As long as you keep it tidy, it's a good way to do it. Now notice -1 divides into -1 one time. Did you ever wonder why a negative divided by a negative is a positive? This is why. It's not a negative divided by a negative is a positive. It's a -1 divided by a -1 goes into itself one time. So that explains that rule. All right, now we'll do the rest. 2 goes into 2 one time. I have a 3 and a 7. N goes into N, another N into another N, a third N, and a fourth N. And I'm left with 3 times 7, which is 21. On the bottom, 2, 2, 2 is 8, N squared. All right, last one we're going to do. 8x cubed over -40x cubed. 8 is 4 times 2, so 2, 2 for the 4, times 2, and then we have x, x, x. On the bottom, I have a -1, and 40 is 4 times 10, so 2 2's for the 4, 2 times 5 for the 10, and then x, x, x. That is now prime factored. 2 divides into 2 one time, 2 into 2, 2 into 2 again, x into x, x into x. All the x's divide out. So remember, they divide to 1. They're not canceling out and disappearing. They divide to 1. So now I got a bunch of 1's on the tops multiplied together, so that would be a 1. On the bottom, I have a -1 times 5, which is a -5. Now, one of the rules for reduction is you can have no negative monomials on the bottom. So you can't end with the negative on the bottom of the fraction. You have to simplify it up. So this is where your old algebra skills come in. That one is a positive. A positive divided by a negative is a negative. So the negative is now on the top. So be very careful that you don't have a negative monomial. And a monomial, of course, is one number. Okay, flip the page. Okay, we're going to do some practice. I'll do the first one with you. We're going to reduce this by prime factoring. So I have a -24. Though negative becomes a -1. You can pick any two numbers that multiply to give you 24. So 6 times 4, 3, 2, 2, 2, an x and an x. On the bottom, a -1. 18 is 2 times 9, so 2, 3, 3, and a single x. -1 goes into -1 one time. 2 goes into 2 one time. 3 goes into 3 one time. X goes into x one time. So we are left with 2 times 2 times x, which is 4x, over a 3. Okay, so what I want you to do is pause the video, and I want you to reduce the last 3 here, and then turn it back on, and we'll go over it, and you can check your work. All right, so go ahead and pause the video. All right, now we are back. So 3y cubed over 27y to the 4th. 3y cubed is pretty simple, 3 and then y. 27 sometimes gives people trouble, so I want to remind you of the rule of threes, which says if the sum of the digits is divisible by 3, the number is divisible by 3. So using this example, 7 plus 2 is 9. 3 will divide into a 9, which means that 3 will divide into 27. Pretty neat trick. So if you're not sure what two numbers multiply to give you 27, use the rule of threes. Divide a 3 out using long division if you need to. You get a 9, so 3, 3, 3, and then 4 y's. 1, 2, 3, 4. Rule of threes is particularly great with large numbers. Okay, divide out a 3, a y, another y, another y. And we've got all ones on the top, 1, 1, 1, 1. And I have a 9y on the bottom. All right, let's do number 3. Negative 30 is negative 1. 30 is 3 times 10, so 3 times 2 times 5. And I have a couple of x's. On the bottom, 12 is 3 times 4, so 3, 2, 2, and 2 x's. Now we're going to divide to 1. 3's divide to 1, 2's divide to 1, x divides to 1, x divides to 1. I have a negative 1 times a 5, which is a negative 5 over a 2. All right, last one, 63p over negative 36. Let's see, 63 is 7 times 9, so 7, 3, 3, and a p. On the bottom, there's a negative 1, and then 6 times 6. So 2, 3 for the first 6, 2, 3 for the second 6. I can divide a 3, I can divide another 3, and that leaves me with 7p over negative 4. We're going to reduce but simplify the negatives. A positive divided by a negative is a negative. 7p over 4. That's the last one. Okay, one of the rules that I didn't talk about on these examples is the rule of tens. The rule of tens says each 0 at the end of a number is a factor of 10. So for example, 3600 is 36, and then there's 2 zeros, so it's times 10 times 10. So every 0 means a multiple of 10. So just a little help with that. All right, so this is reducing ratios. Now we're going to go to solving proportions. Okay, the definition of proportion is an equation stating two ratios are equal. So 2 pounds per 3 square inches is a ratio, and it could be equal to 4 pounds over 6 square inches. This is a proportion. So what do we notice about the proportion? The top quantities, left and right, pounds and pounds, are matching. The bottom quantities, square inches and square inches, are matching. And if it's a true proportion, both fractions reduce to the same number. So the one on the left is 2/3. The one on the right is 4/6. If we factor 4/6 into 2 times 2 over 2 times 3, you can see that the left and the right actually do equal each other. That means it's a proportion. Same units on top, same units on bottom, and the numbers reduce to equal fractions. Okay, so steps for solving proportions. Number 1, use reciprocals to get the x on the top of the fraction or fractions. Then you're going to use reciprocals to eliminate the bottoms from both sides. The third step is you're going to solve for x, which is old stuff. Simplify both sides, add or subtract x terms left and number terms right, and multiply by the reciprocal to get 1x equals your answer. All right, flip the page. We're going to go over some basic proportions, and then I'm going to give you a chance to practice that skill. And I'm going to try to show you techniques that work every time, because it's really easy to learn shortcuts that only work some of the time. Okay, 3x over 14, x minus 2 over 5. So the x's are already on the top, so we don't have to worry about moving the x's, but we do need to simplify by getting rid of the fractions. So one of the easiest ways to simplify every problem on this page is to make the bottoms match. What do I mean by that? Well, this is a 14, that's a 5. So if I multiply the left by 5 over 5 and the right by 14 over 14, now the bottoms match, 5 and 14, 5 and 14. Because the bottoms match, I can now get rid of them by multiplying both sides by 5 times 14 over 1. This will cause the now identical bottoms to cancel out. Look how easy that is. And it works on every problem. Now all I have left is 5 times 3x, the tops, equals x minus 2 times 14, the tops of that one. And now we can do regular solving. So simplify, 5 times 3x is 15x. Backwards distribute the 14, you get 14x minus 28. Solve for x, so I'm going to move the 14 left, so subtract 14x over to the left. You get x equals negative 28. Notice I'm trying to keep my equal signs lined up as much as possible, especially when dealing with lots of fractions. Lining things up can really make a difference. Okay, so example 2, we have a different dilemma, which is that we have x's on the bottom. We can't solve with them on the bottom. So there's a great shortcut step. This is one of the few ones I like to teach because it works so well. If you have a fraction equaling a fraction, and you need to get the bottoms up to the top, you are allowed to flip both sides. Isn't that nifty? So we nickname this flippy step. So on this one, where my x's are on the bottom, if I do flippy step and flip both sides, so I have x plus 1 over 3 equals x over 2, I now have the x's on the top and I can solve. Moving the x's to the top should be your first priority. Now we need to get rid of the fractions, so we're going to do the same thing we did before, make a common denominator and get rid of it. So we're going to multiply the left by 2 over 2, multiply the right by 3 over 3. And most of you are just going to cross the bottoms out at this point, but this is notes. So you're technically multiplying by 2 times 3 over 1, the denominator over 1. And that's why the bottoms cancel out. So now you've got 2 times x plus 1 equals 3x. And you go to normal solving. So I'm just going to put dot, 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 x equals 2. You can finish it if you want, but I'm mainly interested in teaching the proportion steps. All right, example 3. This one, flippy step is not a good choice because if we flip both sides, the x plus 1 will be on the bottom. So what we're going to do is do a common denominator and move it that way. This negative, by the way, looks like it's in front of the fraction. There's actually no such thing as front in math. There's either numerator or denominator. There is no sideinator. So when you see a negative like this, it actually goes to the top. There is no front. So that's really a negative 3 over 4. Okay, so we're going to use the same skill that I was showing you to move the x minus 6 up. We're going to do a common denominator. So I'm going to multiply the left by x minus 16 over itself. Multiply the right by 4 over 4. Oops, let me put that in parentheses. And now that they match, we're going to get rid of them by multiplying both sides by 4 times x minus 16 over 1. This makes all the bottoms cancel out. And now I have x minus 16 times a negative 3 equals x plus 1 times 4. Now, have you ever wondered why they taught you backwards distribution in Algebra 1? This is why. There are times where it is more convenient to go backwards. So I get negative 3 times x is negative 3x. Negative 3 times negative 16 is positive 48. On the right, backwards distribute the 4, you get 4x plus 4. Continuing on with this, if you subtract the 4x to the left, you have negative 7x. If you subtract 48 to the right, you have negative 44. So I need to get this negative 7 off of the x. So just put this over 1. And multiply by the reciprocal, 1 over negative 7, 1 over negative 7. Those will cancel out. And a negative divided by a negative is a positive, so 44 over 7. That's our answer. Do not change it to a decimal form. Leave it exact as a fraction on your homework. Okay, example 4. You have a negative x on the bottom, so we can move it using reciprocals, or we can just do flippy step. Probably flippy step would be the better idea. So now I have 2 over 9 equals negative x over 11. So get a common denominator. I'm going to multiply the right by 9 over 9 and the left by 11 over 11. So when I multiply both sides by 11 times 9 over 1, the bottoms cancel out. 2 times 11 is 22 equals negative 9x. And again, we're going to get the 9 off of the x. We're going to multiply by 1 over negative 9 on both sides. So the 9's cancel. Flip-flop the sides. X equals, and remember a positive divided by a negative is a negative, so it should be negative 22 over 9. Remember, do not end with a negative on the bottom. Okay, we are going to do the practice problems. And again, I want you to pause the video and try to do these on your own, and then restart the video and watch as I go through and see if you have got the right answers. Remember, I'm trying to teach you a new technique because it's one that we can add on to later rather than teaching you shortcuts that will stop working eventually. All right, so go ahead and pause the video. Okay, restarting. Here we go. We need to get rid of the 3 and the 6. So I need a common denominator. I'm going to multiply by 3 over 3 and 6 over 6. So we multiply by the reciprocal, 6 times 3 over 1 on both sides, which causes the bottom to cancel out. Now you might say, but Ms. Reich, isn't 3 a factor of 6? Yes, it is. And you can multiply the left side by 2 over 2. But again, I'm just trying to show you one method that works with all problems rather than giving you multiple methods that you have to choose from. So now I have 6 times x, which is 6x, equals x minus 2 times 3. Backwards distribute the 3. I get 6x equals 3x minus 6. Subtract the 3x over. 3x equals negative 6. So x, of course, must be negative 2 because that times 3 is a negative 6. All right, number 2. This one has x's on the bottom. We need them on the top. Let's do flippy step. Flip the top and the bottom. You get x minus 1 over 1 equals x plus 5 over negative 3. Beautiful. Now I want to get rid of the fractions. So this is a 1. So it's like you're multiplying the right side by 1 over 1. The left side we're going to multiply by negative 3 over negative 3. Now that they have a common denominator, we're going to eliminate it by multiplying by negative 3 over 1 on both sides. That will cancel out the bottoms. And you have negative 3 times x minus 1 equals x plus 5. So finishing this up, distribute the negative 3. Negative 3x plus 3 equals x plus 5. And then we're going to subtract x's left and numbers right. So I get negative 4x equals 2. To get rid of the negative 4, put them over 1 and multiply by 1 over negative 4. I'm a little bit out of room here. I'm going to move over. So now I have x equals 2 over negative 4. And there's two problems with this. The negative's on the bottom and 4 is divisible by 2. So if I factor the top and the bottom, I can divide one of the 2's to 1. Now I have 1 over 2, and a positive divided by a negative is a negative, and it goes up top. All right, these last two, I'm going to start it with you and just see if you get the starting part correct. So number 3, we can't do flippy step because that will just put the x's back on the bottom. Instead, we need a common denominator. So I'm going to make both of these match. You can multiply by 4x over itself and 4 over 4. Or if you recognize that 4 is a multiple of 4x, you can get away with just multiplying by x over x. So again, I'm going to keep it simple. Multiply by 4 over 4. Multiply by 4x over 4x. That gives us a common denominator. To cancel it, we multiply by 4 times 4x over 1. And notice that I'm not interested in multiplying that together because I just know it's going to cancel out anyway. So I'm not going to take the extra step to go to 16x. I'm just going to cancel it as the double factors that it is. Now I'm going to worry about multiplying. I get a 12x equals negative 3x plus 2 times a 4. And then you go on from there. Number 4, which is the last one. To get x to the top, you should definitely do flippy step. So you get 7x over 8 equals 3 over 16. And again, if you want, you can use the fact that 16 is 8 times 2. And then you'll just need to multiply the left by 2 over 2 so that it matches. Or you can do 16 over 16, 8 over 8, and go there. Both of them work. So we get a common denominator and then multiply by its reciprocal, 2 times 8 over 1. Cancels out the bottoms. So now we have 2 times 7x, which is 14x equals 3. Multiply by 1 over 14 on both sides. So the 14 cancels out, and x equals 3 over 14. All right, I hope this was a good review for you. If you have trouble with proportions or ratios, follow the exact same method on all of them, and you will never be wrong. Have a great afternoon.